Alright, in this video we are going to take what we did in the last video with symmetry, and we're going to classify a couple of those symmetries with new special names, even and odd functions. In a nutshell, if you are symmetric to the y-axis, you are even. So even functions are y-axis symmetric. And odd functions are origin symmetric. That's easy to remember. Odd and origin both begin with the letter O. So odd functions are symmetric about the origin. So in the previous section, again that was way back in 1.1, you studied different types of symmetry of a graph. In the terminology of function, a function is said to be even if its graph is symmetric with respect to the y-axis. And it's said to be odd if its graph is symmetric with respect to the origin. The symmetry tests in 1.1 yield the following tests for even and odd functions. Now this notation might get a little confusing once we go through an example or two, especially the way I present it. It'll clear up any confusion. So here's a test. A function y equals f of x is even if for each x in the domain of the function f of negative x is exactly the same as f of x. A function y equals f of x is odd if for each x in the domain of the function, f of negative x is equal to the negative f of x. Okay, again, notice here we're talking about functions. A function is even, a function is odd. So we have our y-axis symmetry taken care of, our origin symmetry. That might lead you to a question in the rattle around the back of your head. Here's our million-dollar question. Why isn't there a special name for a function that is x-axis symmetric? If a function is y-axis symmetric, we call that function even. If the function is origin symmetric, we call it an odd function. Why is there no special name, even, odd, or something else, for a function that is x-axis symmetric? Think about that. Why isn't there a special name for a function that is x-axis symmetric? Okay, let's think. And the keyword here is function. A function is even if it's symmetric to the y-axis. A function is odd if it is symmetric to the origin. Here's my x-axis. A very simple graph that would be symmetric about the x-axis would be a sideways opening parabola. Do you see what I'm going for here? A function, a function. Would this pass the vertical line test? Of course, if I move my vertical line back and forth, it's hitting the graph at more spot than one. So this is not even a function. If you are symmetric to the x-axis, you are not going to be a function at all because it fails the vertical line test. That's why there is no special name for something that is symmetric to the x-axis, because if you're symmetric to x, you are not a function. Okay, here's the example from the book. Notice here in example 8, part A, we got x cubed minus x. This is from our textbook, and I found some other stuff online, and I accidentally did a rerun of that, but that'll just save us more work when we get to example 9. So, I've found a way to present this. Hopefully this will clear up confusion from maybe how it's been seen in the past. When you are testing if a function is even or odd, I always tell my students the first thing to do, if this is g of x, I want you to find negative g of x. And to find negative g of x, I'm just going to take the exact function as they gave it to us, x cubed minus x, and I'm just going to put a negative out front. Don't forget the parentheses because that will need distributed. So I'm putting a negative in front of this g of x, and I'm putting a negative in front of this function and parenthesizing it off. So distribute that negative. So now we have negative x cubed plus x. So our original function is right here. X cubed minus x, I'm going to call that option 1. We negated our function, negative g of x. We distributed that negative. For ease of reference, I'm going to call this option 2. So here are two places we might wind up. And let's see what happens as we continue to go through. So here's our function g of x. We negate that, and now we want to do a test. And here we only got to do one test, and it's always the same. We are going to replace x with negative x. Replace x with negative x, just like we are checking for y-axis symmetry. So I'm going to take the original function, g of x, and now I'm going to run a negative x through it. So that x cubed is going to become negative x, quantity cubed, minus a negative x. So let's algebraically simplify that down with our order of operations. Negative x quantity cubed is negative x cubed, minus a negative, that will turn into an opposite, add the opposite, plus x. So now here's what we got when we did our test. Does that match option 1 or option 2? Well, if we look at option 1, we are not back to where we started. So we are not an even function. But we do perfectly match option 2. If we match option 2, that means our function is odd. So here, g of negative x, that's what I have here underlined. This is g of negative x. That is exactly equal to what we found here, negative g of x. Negative g of x. That is what all this terminology in the box meant. Odd function f of negative x equals negative f of x. We just showed that the negation of the function, negative g of x, is exactly the same as putting a negative through the original function, g of negative x. When that happens, when we match up to option 2, our function is an odd function. So let's look at B here. Here's letter B. I can throw A in the garbage. So those steps will be exactly the same. This is h of x, so I want to find negative h of x. I'm going to take the h of x that they gave me, the quantity x squared plus 1, and I'm going to distribute a negative. So that is going to equal negative x squared minus 1. So now time for the test. We are going to replace, that is an e, replace x with negative x. So here's my original function h of x. I'm going to put a negative x through the function. So that will be now a negative x, quantity squared plus 1. Well, negative x squared is a negative x times a negative x, or a positive x squared plus 1. Does that match option 1, the original function, or does that match option 2, the negated function? Well, it's obvious it does match the original function. So h of x, our original, whoa, that's terrible. Our original function, h of x, is exactly the same as h of negative x. So it didn't matter what we put in, a positive or a negative x, we got the same output. So that makes us an even function. Even functions are y-axis symmetric. And again, back to here, that's what we have right here in our test box. Oops. F of negative x is exactly the same as f of x, and that tells us our function is even. This is a great test if you do not have a graph. You know, it is pretty easy to see symmetry from the graphs. The first one we did was origin symmetric, x cubed minus x. We go right through the origin, and here's the point x comma y. So on the other side of the origin is going to be negative x comma negative y. Origin symmetry. X squared plus 1, we have our upward opening parabola with a y-intercept of positive 1. You know, we did our test, and we plugged in x and negative x, and we got the same output of y. And that told us we are symmetric about the y-axis. So a little bit more in the way of examples to solidify this. Here in example 9, this is again is a repeat. We know for sure that this function was odd. So now if you look at the second one here right below it, it looks pretty much the same, x cubed minus x, but now we got a minus 2 tacked onto the end. Let's see if that messes anything up. So the first thing I want to do is find the negative of my function, the negation of my function. And that just means I'm going to distribute a negative across all of those terms. So over here it will be a negative x cubed plus x plus 2. So again, for ease of reference, here is option 1, the original function. Here is option 2, the negation of the function. Well, now we want to do the test. We are going to replace x with a negative x and see what pops out. Why are my parentheses so bad? There we go. So our original function f of x, we will now replace all x's with a negative x. So that's going to be negative x quantity cubed minus a negative x minus 2. So we've done some of this stuff before. We've already talked about a negative x quantity cubed. That turns into minus x cubed. Minus a negative x, that will turn into a plus x. And then we have our minus 2 does not change. So does that match option 1? That would show us we have an even function. No, the leading term is off. Here it is a positive x cubed. Down here it's a negative x cubed. So it's definitely not option 1 or an even function. So let's go to this one, the odd one. Ooh, we got negative x cubed here, negative x cubed, looking good. We got a plus x also looking good. Uh-oh. Here it is a plus 2, here it is a minus 2. So it's not option 1, we're not even. It's not option 2, it's not odd, it is neither. Our only options are even, odd, or neither. And here it wasn't even, it wasn't odd, so by default it must be neither even nor odd. For the next one, now we have f of x equals x squared. Well, negative f of x, that's an easy one to find. If I just negate the x squared, I have minus x squared. So let's replace all our x's now with negative x's and see if we have any type of symmetry. So f of negative x is simply negative x quantity squared. Well, negative x times negative x is positive x squared. Does that match option 1, the original function? Yes, it does. And it automatically does not match option 2, the negated function. So if our function is exactly the same, if f of x is the same as f of negative x, we have just found an even function. And let's see what we have here. Notice now we have the same x squared, but now it's a minus 6. When we did the first one, this one was odd. And when we tacked on the constant, this was neither. N-E-I-T-H-E-R. So if you have an odd function and you tack on just a constant, it is going to mess up the symmetry. Let's see if a constant messes up the symmetry here on an even function. So our my negative f of x is going to be, of course, negative x squared plus 6. And if I do my test, I'm going to replace x with a negative x. There we go. So f of negative x is equal to negative x quantity squared minus 6. Just like in the last part, negative x quantity squared is positive x squared, and then the minus 6 just comes down. So does that match option 2, the negated function? No, it does not. So we're not odd. Does it match the original function, x squared minus 6? Oh, yes, it does. So we match the original function, or what I'm calling option 1 here. F of x is exactly equal to f of negative x, so we just found an even function. Remember, here in the odd function, a constant messed it up. It changed us from odd to neither. When we just checked these last two, x squared was even. X squared minus 6 was also even. So constants do not mess up the symmetry of even functions. Okay, 2 problems to practice with, number 83 and 84. So pause the video and try those out and see if you have any type of symmetry or if it is a neither. Make this a little bigger here. Okay, the first one, we got some bigger exponents here, but that's nothing to worry about. If I find the negation of this, that would be negative f of x will be negative x to the 6th plus 2x squared minus 3. That's supposed to be a squared. Minus 3. So let's replace all x's with a negative x. So this will be a minus x quantity squared plus 3. So let's think about this. We have a negative x to the sixth. Think about just the sign of it. We're going to multiply a negative times 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 a negative 6 times. Well, this negative times negative is positive. This negative times negative is positive, as are these last two negatives positive. If you multiply 3 positives, you get another positive. So this all turns into just an x to the sixth. Negative x squared is positive x squared, and then so that'll be minus 2x squared, and then we have our plus 3. Does that match the original function or the negated function? Well, of course, it matches the original. So if f of x is equal to f of negative x, we have an even function. Even. All right, and 84. Now our function name is h of x. So the negation of h of x is going to be negative x cubed plus 5. So here is option 1. If we get that, we're even. Here is option 2. If we get that, we are odd. So let's replace all x's with a negative x in our function. That will become a negative x cubed minus 5. So negative x times negative x times negative x is negative x cubed minus 5. Does that match option 1, the original function, therefore making it an even function? No, we don't have the negative in front of the x cubed. Does it match the odd function, negative x cubed plus 5? No, we are missing the plus in front of the 5. So it's not odd, it's not even, it's neither. It has no symmetry at all. And I believe that's the end here. There is a worksheet for homework. If I remember right, I don't think I put 87 on the worksheet, but the rest of them are on there. So if you don't have the worksheet, copy those down and do the test for even, odd, or even or odd symmetry, or neither. Alrighty, have fun.